Section 9.6, Graphing Linear Inequalities in Two Variables. In this video, we are going to learn how to graph linear inequalities. In our first example, we want to graph the half plane that satisfies the inequality y is less than or equal to negative 2x plus 3. So what we want to do is treat this as if we're graphing y equals negative 2x plus 3 to start with. So since we're in slope-intercept form, we know that our slope is negative 2, and we'll put that over 1 to make it a fraction. So I have my rise over run. And we know that our b is 3. So just going back like we've previously graphed, we're going to start at 3 on the y-axis, and then we'll go down 2 over 1. Now, when I look back at the inequality, this is the difference between graphing an inequality and graphing a line. First thing I need to do is look to see whether or not this is a less than, a greater than, or if it includes an equal to. If it includes an equal to, like this one where it's less than or equal to, then I'm going to connect my dots with a solid line. If that didn't have an equal to, then I would want to connect it with a dotted line. Now the next thing we want to realize is there's actually an infinite number of points that would make this equation or this inequality true. So what we're going to do is we're going to shade all of the points that would make it true. Since it's a less than problem, then I'm going to shade everything that's below or less than the line. So my solution would be all of these points below the line. So I shade everything that would be below the line. And then that shaded area is the solution to the graph of y is less than or equal to negative 2x plus 3. Now let's look at the graph y is greater than 2x. So again, we're in slope-intercept form. Our m is going to be 2, so we'll write that as 2 over 1. And this time our b is 0. Because we could imagine that we could add a plus 0 on the end of that. So our rise is 2, our run is 1, and we're going to start at 0. So we'll start on the y-axis at 0, and then we'll go up 2 over 1. Now this time, if I look at my inequality sign, it's not an equal to problem. It's just greater than. So then I want to connect my dots for my line in a dotted line because I'm not allowed to equal the points that are on the line. So I'll still go ahead and draw it with arrowheads to show that it's going to go on, but I have a dotted line or a dashed line. Now I want to be greater than that line. So what that tells me is I will shade everything that's above the graph. So I want to shade all of the stuff that would fall above the graph. So all of the points then that fall in that shaded area would make that inequality true. So let's just look at that very quickly at how I would check that. I can pick any point over here, let's say at negative 2, 2. And I can test that in my inequality and show that it's going to make it true. So let's just take this inequality, y is greater than 2x, and let's put in the point negative 2, 2. So 2 is greater than 2 times negative 2. 2 is greater than negative 4, and that's true. If I pick a point like 1, 6, that would be on the shaded part. I'd have 6 is greater than 2 times 1. 6 is greater than 2. That is true. So that point is also shaded. Then let's pick a point that wouldn't work in the inequality just so that we can see that. So if I pick a point that's not shaded, let's say 3, 0. So we're going to use the point 3, 0. And we'll do 0 is greater than 2 times 3. 0 is greater than 6. Well, that's false. So notice that that side of the graph did not get shaded. Now we're going to graph the inequality y is greater than 1. Well, we recall that if you have y equals a number, those are horizontal lines. So since this doesn't have any x with it, y is greater than 1, we go to 1 on our y-axis. Since we're not allowed to be equal to 1, we're just going to draw a dashed horizontal line at 1. And notice that it says I have to be greater than 1. So then I want to shade everything that would be above 1. So there would be my half plane that would satisfy the equation or the inequality y is greater than 1. How about x is less than or equal to 0? So again, we know that x equals a number is a vertical line. So since this just has x and a number, we're going to go to 0 on the x-axis. And since we can be equal to it, we'll draw a solid line. And then I've got to be numbers that are greater than 0. Well, greater than 0 would be to the right of my number line or to the right of my axis. So then here's the part that we're looking at, where the x numbers are greater than 0, which would be these. So there's my solution. So again, rather than getting 1 point for a solution, we have an infinite number of points that make that inequality true, and so we're shading all of them. In our last example, we're trying to graph 2x plus y is less than or equal to 4. So what I'm going to do is I'm going to go ahead and solve this for y equals, because we can only quickly do the shading if we solve for slope-intercept form. So let's subtract 2x. So y is less than or equal to negative 2x plus 4. So my m is negative 2, and we'll go ahead and put that over 1, and my b is 4. So we're going to start at 4, and our slope is down 2 over 1. Since it's an equal to problem, we're going to connect the dots with a solid line. So now I want to take those dots and connect them. And the last thing is, how do I shade it? Well, notice that it's a less than or equal to. So since it's less than, I want to be below that line. So here is your solution. Everything that's below the line, which will be that section there.